what we have should be 80.445, because here is 4, it's at the middle, 45. Now the lowest value there we have 20. This is 30. This is 30. That means minus 30.00 all over. We'll come here. The highest point here is, I think is 0.045. We have 0.045. Then minus the lowest value. We have what we have here is 0.01. This is 0.0. This middle point should be about 0.015. That means 0.015. So let's see what we have, what it look like. 80.45 minus 30. We have our 50.45 all over 0.045 minus 0.015. We have 0.03. That means now 50.45 divided by 0.0. What we have will be, what we have our slope will then be, this will be equal. No. Now this will be gram per watt. This inverse will then be inverse of it will give us a cm, gram cm, because this is our slope. This is our slope now. So I think we have come to the end. There are other small questions that you should be expecting, like precautions. One of the precautions should be that you avoided parallel error, and then make sure that the second one, you should also make sure that it balance at the knife edge before you take your reading. And then one of the precautions, you make sure that the table or whatever you're using is very, very balanced. On the knife edge is well balanced. Not you should not put it in a table that will be shaking. So when it shakes so much like that, it might likely give you error. But the basic error there, just avoid parallel error and then make sure it's balanced effectively before you take your readings. Now this is where I'm going to stop our class for now. Thank you so much for being part of it. And if you have any question, you can also leave it in the comment section. I will always attend to you. Thank you. So welcome to Study Guide Forum. Today we'll be looking at the first question in the physics practical. If you can still remember, we have a meter rule. We have 100 grams. This is 100 grams here. This is 100 grams. And this is just what I believe in my own prediction that is likely to appear. So the 100 gram will be marked here. 30 cm from the zero marking there. Then the meter will be balanced at the knife edge, and the point, the center of gravity will be noted So we note the gravity, and then this other one, the masses will be varied. You adjust it, you adjust this mass to the point it will balance, the point where it will balance with what we have there, that is 100 grams. So in this case, where there are some values that we're going to be looking at, which means you are going to be looking at maybe the mass. We'll get the mass. The next one we'll be looking at also will be we'll get the x. Then we can calculate d, which will be equal to y minus x. Then this d again, we can also look at the d inverse. So with this, we're likely to be plotting a graph of mass against d, or d inverse. And these are some of the things I'm going to be showing in this video. I'm going to show you how to plot this graph, mass and d, and then mass and d inverse. We're going to be looking at how to choose the scale, how to do this practical actually, which we are going to be doing after now. I want to encourage you to stay with us, stay and watch to the end, so that I'll be able to face this scene, the particular one, with ease in the exam. So let's dive into the main thing. So we are about to start the experiments. Now what I have here, the first thing the question said we should do here is to balance it. To balance it in the middle row in the knife edge. That will be the first thing to be done. Now it's like it's balanced. Yeah, it's balanced. Let's see. To push it a little. Which one is balanced? So it's balanced now. Now we have the center of gravity. We record it's around 50 cm. We record 50 cm. Now the next one they say you should do is to use an adhesive and then fix this 100 mass at what 30 cm marking of this meter rule. And I've done that. So we have it at 30 cm. Then the question says we should allow it, we should not move it from that position. Since I have the center of gravity, I place it back there. Then the first mass we are going to be using in the other end of it is 50 cm. 50 cm, that's what we are using the first one. So that a 50 cm, 50 grams, sorry. 50 grams, so I'm using 60 grams now. 50 grams in there. It's not balance. See coming down. Okay, it's like it's balanced here now. You can see. Let's see if we can shift it a little. balanced now. You can see it's balanced. It's not even going down like that. You see the balance actually interesting. Okay, it's not better now. Yeah, it's balanced at this point. So we take the measurement, say that the distance between from this point to that, we're going to take the measurement. We have here to be 50. Then what we have at this point is this place is 1, okay, that's about 9.8. To get this one now, it will be 9.8 subtracts 9.50 minus 9.8. We have 42. The distance here, that distance in cm is what? Sorry, 40.80, not 42, 40.80. That's what we have at this point. So the next one says we are going to repeat it by using 60 grams. This is already 50 here. What I do is just to add 10 grams to it. I'm adding 10 grams. So this is my 10 grams. I add the 10 grams to it. Then I adjust it again. I think that it remaining small now. Yeah, it's balanced now. It balances at 16.6. 16.6. This place we have 50. Since we have 50 minus 16.6, we have 33 cm, 33.40. So note, the distance we are looking for is this one, between these ends, and why this other one is steady. That one is steady to be at 30 cm. 30 cm. From this end, we have 30 cm there. So now the next one, we have 70. This is, we're going to be using 70 now. I'll do just to add 20 to it, 20 grams. In this, it's important that you know how to do this thing so that you do not have an issue. And then I will also show you how to plot the graph of this to choose your scale, which used to be the biggest problem most students used to have in the exam. What's wrong with this thing? Right, it's gone. Into an exchange position. That's balanced now. This one is balanced. It's balanced at 22. Here it's 50 minus 22. We have 28.00 this time. So we'll go to this is 70 we have, we'll go to 80 now. Okay, that's balanced. Balance at what? You see. There's something better than this. Yeah, that's balanced. So what we have here is 25.1. 50 minus 25.1. We have 24.90. So the last one we have 90 grams. So to get 90 grams, what we do is to, I think I should get another 20 grams here. So I think I can leave it like this. This now is 90. We're trying to balance it. I'm not sure that this one is steady. It's even balanced. Then move it a bit. So we have it. It's balanced. It's balanced at 28. 28. Actually, yes, 28. 28. That means 50 minus 28. We have 22. 22.00. That's what we have. The next thing we're going to be doing now is to plot the graph, which will continue in the we're going to go into the other graph session. Now we have this thing done. So we're going over to the next stage of this. So this is the value that we have at the end of the practical. Now, as you can see, these are the values of the x. To get the d is y. X subtract from y, you get the d. Then this is the D inverse, and this is what the values, the approximate value of this, which we are going to be using for the graph. This is what we are going to be using for the graph. Now, in the graph, one of the ways of plotting the graph is that when you want to plot this graph, you will consider, you look at the highest value and the lowest, the minimum and the maximum value in your graph. So let's go over to, let me see if okay, I think this one is better. So we're going to be plotting the graph here. Now in this graph, there's something I want to point out clear here. In this graph, these big blocks, see the thick lines. Can you see the thick lines? In the exam you're writing, these thick lines in their own graph, it represents that's for WAEC exams. These thick lines you see here stand for 2 cm, and inside it you have 1 2 3 4 5 6 7 8 9 10. That means something like you can say 10 lines. You have 10 lines, 9 small lines before you get the next 10 line. This is considered, when you want to plot your graph, you consider these lines. We have it to be 10 cm, 2 cm. In the normal graph that you can see perhaps in the market, it's normally 4 lines in between the thick lines. That 4 lines in between the thick line gives you the what is stand for 1 cm. So this one you have you can say that is this from here to that place is 8 lines, 8 small lines, then adding 1 2 3 4 5 6 7 8 9. Okay, 9 small lines inside it. Then 10, we have a 2 cm. So which means each box starts for 2 cm. That's how to know your scale. That's one of the things you need to understand about your scaling in this. So now we will consider the highest value. In the graph we're plotting M against a D inverse. That's the first one we're going to do. We're going to plot M against D inverse. So M in the vertical axis, meaning that we are going to be taking, first let's find out what the inverse will give us in the horizontal axis. You see, I think the lowest minimum is 0.025. Then the maximum is what? 0.046. That's the maximum. That means our graph in the horizontal will be like this. Let's say we're taking, okay, this will be 0.01, this is 0.02, 0.02, 0.01 will be here. If we are choosing here to be our 0, our beginning, or the origin. So 0.01, 0.02, 0.03. It looks so small. Remember, the graph should always be 3 over 4. That is 3 over 4, 3/4. Should take the 3/4 of the graph paper. So now, if I choose 2 cm for 0.01 units, it will be a bit small in the horizontal axis. So I need to expand it. To expand it now, I can take here to be what? That means, remember I told you that from one big line to the next is 2 cm. So if I jump over to this second one, that means I'm using 4 cm. I can say 0.01 here. This other one again will give us 0.02, 0.03. This one is 0.04. Now this one is settled. Then we can also say 0.05 here. We have already settled this matter now. We have settled the matter in the horizontal axis. So in our vertical axis, let's see what we have. The minimum is 50. The maximum is 90. Let's check it. We have, okay, 10, 20, 30, 40, 50. No, you can say 20, 20, 60, 80, I think 10. Did that make it okay? 20, 30, 40, 50. No. 2, 4, 6, 8, 10. That means 20, 40, 2, 4, 60, 80, and then we have our 100. Now, what I've done here now, what I'm taking is, remember, from this bus to this other one, we have our 2 cm. So what I'm taking here is, from here to you have 20, meaning that this one is 10. We can say that we have here in the y-axis, let me put in the y-axis, what we have is 2 cm, 2 cm to what? 2 cm towards 10 units in this axis. Now in the x-axis, since I said 0.01 stand for what? This is first block, this is 2 cm. Second block again, first block from here to here is 2 cm. From here to here is 2 cm. From here to here is now 4 cm. So which means we have 0.01. That means 4 cm. 4 cm towards 0.01 units. That is what we have. Or you can say 2 cm towards, since it's 0.01. Okay, still okay, let's just leave it like that. So the next thing we are doing now is to go over to we're going over to the plotting. Now when we have 0.025, the mass, remember to put your m, the unit, this is in grams, so in g, grams, and then we'll make our Cartesian plane, draw our Cartesian plane. In the Cartesian plane, So from our graph, when for our graph now we have 0.025, we have 25 here, we have 25, 0.02 here. That means if you come from here, you have 1. You see, because we're using 4 cm now, it means that from this point we leave the first line, that is 1. Once we cut, let's say once we cut 2 lines, 1 2, this is 1, 1 2 again, 2, 1 2 again, 3, 1 2 again, 4, 1 2 again, 5 at the middle. Can you see that? See, we get it here now. At that center, this is where we have our 0.025 is here. So what we do, we have a 0.25, we locate the point that is 50. If you follow this line, you can see 50 somewhere here, because here is 60, here is 40, here is 60, here is 40. The middle of them should be 50. So we leave it here. So say, look at it, 40, 60, here is 50. So we'll leave a point there. The next one we are going to be doing now will then be, we'll come over, we have the next is 0.030 when it's 60. Then this is 3. That means we are moving up here to locate 60. This is 60 now. We'll put it here. This is our 0.03. So we have it. The next one we have here will then be, this is 0.031. What do we do here? We look for, is it 31? 0.036, not 1, sorry. So this is 3. Remember, this middle will give us 5, like we've done before. This middle will give us 5. So the next one will count 1 2. This one will be 6. So we'll locate 70. Locating 70 means that I think I should use a rule to get it straight. Locating 70 now, this is 60. So 70 is the middle line between 80 and 60. So this is what we have here. That's it, 70. So the next one we have is 0.040. So this is our 4. Then we have it, the mass is what, 80. Then we'll move up. The 80 mark is here. So now you can see what you have. The last one now is 90. In 90 we have 0.046. We have our 5 here, like I said before. You can see this place is 5 now. 1 2, we have our 6. So then we'll go up now to locate 90. This is 90. This is where we have it. So we join the line to make a straight, to join the graph. You see that all of them are, we don't have much deviation. Wow. So this is what our graph look like. You can see what it looks like. So the next thing we're going to be doing is to find the slope. In finding the slope, what we do here is we choose the points. It's always nice to take a very large distance slope. You can say I'm taking from this point down here, journey to this place. So now we're going to choose remember our slope is always a change in what equal to change. This is our mass over change in what the inverse. So our change in mass will then be, we look at this point here. We have 80, then the 80 is not actually up to, from here we find out we have 1 2 3 4, this is 5, that means 4 points. That's about what we have should be 80.445, because here is 4, it's at the middle, 45. Now the lowest value there we have 20, this is 30, that means minus 30.00 all over. We'll come here, the highest point here is, I think is 0.045. We have 0.045, then minus the lowest value we have what we have here is 0.01. This is 0.0, this middle point should be about 0.015, that means 0.015. so let's see what we have, what it look like. 80.45 minus 30, we have our 50.45 all over 0.045 minus 0.015, we have 0.03. That means now 50.45 divided by 0.0, what we have will be, our slope will then be, this will be equal, no, now this will be gram per watt. This inverse will then be, inverse of it will give us a cm, gram cm, because this is our slope. Now. So I think we have come to the end. There are other small question that you should be expecting, like precautions. One of the precautions should be that you avoided parallel error, and then make sure that the second one, you should also make sure that it balance at the knife edge before you take your reading. And then one of the precautions, you make sure that the table or whatever you're using is very, very balanced. On the knife edge is well balanced, not you should not put it in a table that will be shaking. You know, when it shakes so much like that, it might likely give you error. But the basic error there, just avoid parallel error and then make sure it's balanced effectively before you take your readings. Now, this is where I'm going to stop our class for now. Thank you so much for being part of it. And if you have any question, you can also leave it in the comment section. I will always attend to you. Thank you.